Hello dear student, I am Monur Islam. Today in this video we are going to discuss some important question of real analysis. Okay, we all know today CSR 2022 notification has come. Okay, so from today now we'll start a preparation or journey for preparation of CSIRNET. Okay, June 2022. Okay, and I will upload topic as video. Today I have started real analysis and I will upload one by one topic videos of real analysis. After that I upload video of linear algebra. Okay, after that complex analysis and model algebra. Okay, if you when pure topics are covered, then I will upload the video of applied section. Okay, so please subscribe my channel and follow my channel. You will get all thing in my channel. Okay, so today we start real analysis. So let's start. And today is my topic is first chapter. It is the first chapter. Okay, continuity. We do what we do here. We will do question of previous year question. Okay, we will discuss previous year question. We will not only discuss previous year question, but we will I give the theory that we will need to solve the question. Okay, and we'll discuss many question and more question that will be possible. Okay, so let's start. And I will discuss brief theory about that will be needed. Okay, so let's start from first question, and hopefully this session will be helpful. Okay, so let's start. So this is the first question. Okay, I will discuss the theory that we will need in every question. Okay, and okay, so please give me a feedback after the class. Okay, so let's start. It says that SBI card is a question of CSIRNET December 2011. Okay, so this is a question. SBI card is subset of real number. SBI card is subset of real number. Okay, every element is irrational, then card negative x. Okay, so see, we all know a subset of R. You know, this is the result. Okay, what is the result? I am writing the result. Let A be a subset of R, so real number, then A is connected. Okay, then A is connected if and only A is either an interval, an interval, maybe open interval, close interval, or maybe half open, half closed interval. Okay, maybe interval, either an interval or a singleton set. Okay, either interval or singleton set. Okay, so here it says x is current subset of real number. Okay, so from here you understood that x is either an interval or a single set. Okay, this is the two possible cases. Okay, but it says if every element of x is irrational. Okay, this is the second restriction. Every element of x is irrational. Suppose x is the interval. The two possibility of this from here, since A is connected, since given x is connected subset of R. So from here it is implied that x is interval. Okay, x is an interval, either interval or a singleton set. Now first, if assume x is interval. Suppose x is interval. Interval of R will be form like this. Either it may be open interval or it may be closed interval. Okay, whatever may be, or it may be interval of the type suppose a comma infinity, or maybe type minus infinity comma b. Okay, so if any of the form, then you see between any two real number a and b there is infinitely many rational as well as irrational number. Okay, so suppose for combination if you assume a x be this interval, closed interval ab. Okay, so this closed interval ab, it says every element of x is irrational. Okay, every element of x is irrational. If x is closed interval ab, then you will easily understand. Then this closed interval contains rational irrational also. Okay, this interval contains this interval contain rational as well as irrational rows. Okay, if the interval, then it always contain rational as well as irrational. Okay, so it is not possible if it interval, then it contain only irrational. Okay, so interval is main possible, interval is not possible. X. Okay, so what will be the possible case? X is only single set, because if X is single set of the form, suppose X is be the form this single X is the single set A, where A is irrational. It is possible. Okay, A is irrational, then the single set is connected, so it is connected, connected to R, and it contains only one element. Okay, so cardinal to X will be, and it is contain only irrational element, cardinal to X will be 1, so cardinal to X will be 1. So hope you understand the solution. This question solution will be, answer will be 1. So what is the cardinal to X will be 1. Option D will be right. This question correct will be option 4. So now let's come to the next question. It says that consider the following set on R. W be the set of all constant function, set of all polynomial function, set of Y be the set of all continuous function, and Z be the set of all function. Okay, so from here you can create a relation. Okay, see the constant functions of the form like this: f is equal to c, where c is constant for x belongs to R. Okay, this is the form of constant function. So we all know constant function is a polynomial. Okay, it's a polynomial of degree 0, you can say polynomial, but it is also polynomial, or also constant function continuous. Okay, also it is a function. So you can say set of all constant function W will be subset of set of all x, set of all polynomial. Okay, because every constant function is a polynomial. You can say x is subset of y, because every polynomial is a constant function. Now you can say every constant function is a function, so it is subset of z. Now we know result of cardinality. If a less than is subset b, then cardinality of x will be less than of cardinality of b. Okay, less than equal to cardinality of y, less than equal to cardinality of z. Okay, this is the result of cardinality. You have to remind this. Okay, in cardinality set, in cardinality of a set, we know this result. If a set is subset of b, then it is obvious that cardinality of a means number element a will be number less equal to number element b. Okay, it is very much obvious. So now constant function, what is possibility of constant function? This constant may be constant unconditional choice, because this constant came from real number, but this is C has unconditional choice, so W, this set is uncountable element, so you can say it's connected to C. C means not C, is continuum. It's continuum, means uncountable. So C, so W is uncountable element. Since W is uncountable element, but and current will be greater than C, so it will, from here you can say current of x, current of y, and current of z will be greater than or equal to C, and will be also quantum. Okay, and this is equal to current of W. So all set of current same quantum, because if current of W will be C and current of W less equal to current of x. Okay, is C, so it is greater than C, and also since x is a subset of x with a set of all polynomial function on R. Okay, so you can say it is current will be less equal to C also. Okay, so from here you can say get current will be equal to C. So similarly you can get current of Y also C, current of Z also C. Okay, so all set of current is same. So all of set is current is same. So in question the last 4 option 4 is correct. Okay, so only W same current no, only W is no, only X is no, so all set of same cardinality. So option 4 is correct. Okay, now came to next question. Okay, this is the set of all, this question is about the number of function. Okay, so I am writing the result of number of function one by one. Okay, I am writing the result of number of function one by one. So result is that, suppose let A be a subset of R and it has m element. Okay, and B be a subset of R, real root function, subset of real number, it is n element. Okay, then you can say the total number of function will be cardinality of B will be cardinality of A. Okay, means is current into n, and total number of, you can say, one function means injective function. Okay, this will be read in later, so I have written now. Total on function, total number means injective function will be n pm per meter time. Okay, so you can break this is like n factorial upon n minus m sub factorial. So from here, you since factorial, so you can see from here you can easily get n greater than m. So coordinate of the codomain must be greater than the coordinate of the domain if it injective function. Okay, now total number of, now that will require in the question, total number on to function means surjective function. Total number of surjective function. This is a large formula. Summation over I equal to 0 to n. Okay, this will be minus n to the I, and c I means combination n minus I whole to 1. This is the formula. Okay, so here n is total number surjective map from a total number surjective means it is asking this total number surjective map from a set A, from set A to B, where A contains 4 elements and B contains 3 elements. Okay, and how much is cardinality you're asking, and this function is on to in surjective. Okay, so A content means here M is 4, N is 3. Okay, M is 4, N is 3. So put the formula, you put in the formula, then it gives summation I equal to 0 to n minus 1 to I, n is 3. How much n? N is 3, I think. N is 3, m is 4. I, n is 3, I is 4. Okay, so break it. If I to 0 means 1, 3c0 means 1, 3 minus means 8 to 4, 0 4 plus 1 if 3c1, 3c1 and 3 minus 1, 2 to 4. Okay, now it gives minus 2, so this gives 1. 3c2 means 3c2 and 3 minus 2 power 1, so this is 1. Okay, and if you put 3, this gives 0 because it gives 0 if you put 3. Now it gives 3 to 4 means 81, 3 1 means 3 factorial minus 1 2 factorial 2 factorial 1 factorial. Okay, and 2 to 4 means 16. 3c2 means 3 factorial minus 1 factorial, and this gives 2 factorial. Okay, so this gives 81 minus 3 factorial, it will be 16, 3 factorial and 2 factorial 3. So this gives 81, 48 plus 3. So this is 81 minus 45. So it will be this 36, I think. 36. Okay. So total number on to function will be 36. So hope you understand this question. So the answer will be 36. 36. So in the question of correct will be option 1. Option 1 is correct. Okay. Now these are all questions from part B. Okay, these are all questions from part B. Now we are going to discuss a question from part C. Okay. Now we are going to discuss a question from part C, so that your concept will be clear. After the question of part C. Okay. Now see this question. This question of part C. This question came in December. CSIRNET December 2017. Okay. See what is this question says. It going to says, and the theory that we will discuss. Okay, don't worry. So let's start. For a set X, it says that for a set X, Px will be the set of all subset of X. Means P is the power set. Okay. For set X, Px is the power set. For any set X, power set of X, and omega x is nothing but a set of all function from X to 0. Means omega x is nothing but set of all function F mapping from X to 2 points at 0 1. Okay, this function omega is the set of all function F to 0 1. You can say like this: omega is the set of all those F, those are mapping from X to 2 points at 0 1. Okay. Now see it says if X is finite, then Px is finite. Okay, so we are going to verify each option one by one. See if X is finite, so X finite means suppose let X contains n element. Okay, maybe suppose x1, x2, xn. Okay, so if x contain element, then coordinate of x will be n. Okay, and we all know important result. What is the result? If the coordinate of power set x will be nothing but coordinate of to the power coordinate of x. Okay, this is the result. Okay, this is the result of real analysis, and we have proved also it. Okay, so I am not going to prove it. Okay, I am only giving the result. If we get time, we must prove this. Okay, so power secretary. Current of power secretary is nothing but 2 to the power current of x. So current of x will be n. So this is 2 to the power n. But now 2 to the power n is finite quantity, right? Because even n is 3. Suppose n is 3. If it's 3, then it contains 2 means 8 element. Okay. So whatever may be n, then it will be going to finite. So since 5p is finite, so px will be finite. So option 1 is correct. Now going to option 2. If x and y are finite set, if there is a one-on correspondence between px and py, okay, there is a one-on correspondence between x and y also. So now see option. If x and y are finite, means both x contains, suppose I am assuming x contains n element, let x contain n element and y contain m element. Okay, finite set, so it contains finite elements. So I am assuming first one contains x element, n element, and second one contains m element. Now it says that there is a on correspondence, means there is on byte map, there is on correspondence between px and py. Okay, it is given. What is given? There is on correspondence between px and py. So since there is on correspondence between px and py, from here you can say easily that current of px will be equal to current of py. Okay. See, this is the on correspondence, so means that both they have current is same. So now current of positive will be current of x. Okay, is current of y. You can say. So you can say from 2 to x will be y, means current of x will be current of y. Very much obvious. Okay. If you take log to, from here you can take log to both side. If you take log to both side, so this gives outside, so current of x will be current of y. So this current of x will be current of y. From here you can say to finite set, it is finite set, it is also finite. Okay, both are finite set and both are finite same. So from here you can easily tell that they byte means these two set are equivalent. Okay, since both are finite set and both are current same, so from here you can say that there is one correspondence between x and y. Okay, so option 2 is also correct. Hope you understand. Okay, now going to option 3. Okay, since there is a one correspondence, there is no one correspondence between x and px. There is no one correspondence between x and px. There is no one correspondence between x and px. Option 3. Okay, I am writing here. Okay, this solution I am writing. It's saying there is no one correspondence between x and px. Suppose there is a one correspondence between x and px. Okay, suppose if possible let there is a one correspondence, if possible let there is a one correspondence, if possible let there is a one correspondence between x and px, means there is a mapping, you can say x to px, there is a mapping from x to px which is bijective. Okay, you can say there is mapping from x to px which is bijective. Okay, so from here you can say there is mapping, suppose f inverse from px to x is also bijective. Okay, so since this is a mapping bijective, so there is a in between two sets there is an on mapping. You can say there is on mapping means injective map from x to px. Okay, since it is injective, so you can say current of px domain will less equal to current of x. Okay, now current of px will be 2 to the power current of x. Okay, it will be less than current of x, but it is never true. Okay, 2 to the power current of x never less than 2 to the power current of x will be never less than current of x. Is the contradiction. Okay, this is a quantization. So x is never equivalent to px. X is not equivalent to px. So they are not that other is on correspondence between x and px. Okay, in this experiment there is no on correspondence between x and px, so this option is also right. Now going to option 4, there is on correspondence between omega s and px. Okay, see what is px? There is on correspondence between x and px. See option 4. Okay. Px, so you can write current of px will be nothing but current of partial x, so it will be current to the current of x. Okay, now current of omega x is nothing but separable function. Okay, omega is nothing but separable function from x to 2 point set close 0. Okay, so we have discussed a formula in previous that if f is a function from a to b, f is a function from a to b, total function from set A, total you can say this f such that f from A to B, total function from A to B, this should be this n to m. Total function from a set A containing a set A containing m element to a set B containing n element will be n to m. Okay, so from here you can say easily that since omega is the setable function, since omega is nothing but the setable function, setable f such that f from x to 2 point set close open to 0 on. Okay, so here a is this and b is this, and a has current x and b has current how many element? Current is number of elements will 2. So total function from the set x to 2 point set 0 on will be nothing but current b means 2, b is currently 2, and currently b means current of x, current b to the current of a means 2 to the current of x, so both are same. Okay, so we understand. So from here you can say that current of 2 to the power x will be, this will be y, right? Omega is px. Both sets of current is same, so you can say current of px will be equal to current of omega s. Since both are finite set, okay, see this is finite, so if x is finite then this will be finite. Okay, and both set of current is same. Since both set of current is same, so you can say if x is finite then it's finite. It may not be always finite. Okay, but if x is finite then this is finite. Now you have understand that current of px will be current of settled function from x to 2 point set close 0. Okay, since two set is current same, if two set is current same current, then there is a on correspondence between x and px. Okay, so there is on correspondence between x and px. So option 4 is also right. Okay, so hope you understand this question. Okay, there is a part C question in market 4.75. So in this question all options correct. Okay, option 1, 2, 3, 4. Option 1, 2, 3, 4 all are correct. Okay, now let's go to the next question. I want to discuss some important question also. This some question left we will discuss in tomorrow class. Okay, so don't worry, we will discuss all question. So now go to this interesting question. This question: which the following set are uncountable? Okay, which the following set are uncountable? This is the question. Writing ornament. First of all, name the set S1. Name it A, B, such that A, those will start to such that you can say A less equal to B. Okay, A less equal to B. See here, A is less equal to B. So it may be happen that A is equal to A. So you can say this set always. You can say therefore this set contains this set A, A such that A belongs to R. Okay, this subset S1. Okay, because if the member of the set will be A, B such that A is equal to B. So it may be happen that A equal to A. So this set will be subset of this set. Now this set you can name it as this set contains infinite number element, because this set has this element is coming from R, so this is uncountable choice. Also this element has uncountable choice, so total choice will be C cross C. Also total number of element of this set will be C cross C. C means continuum. Okay, here C means not C English letter C. It is continuum, means continuum. Okay, coordinate of R, we all know coordinate of R will be C, and C is continuum. C is, you can write is suitable aleph knot. Now what is aleph knot? Aleph knot is coordinate of natural number. Okay, coordinate of natural number. We all know in the concept of continuity there are only two numbers. Okay, one is aleph knot and another is continuous. In between there is no number. Okay, in between there is no number, and aleph knot is less than equal to C, and C is to the aleph knot. Okay, this is the relation between this. Okay, there are no set can be no countable set can be cardinality greater than this, and all uncountable set must have cardinality C. Okay, if a set is countable, we all know if a set is countable, then cardinality is aleph knot. If a set is uncountable, then its cardinality will be C, continuum. Okay, so this set has cardinality C cross means C square, and C square means also C. Okay, so this set is uncountable. This set will be uncountable. So this is uncountable, and this will contain this set. So this S1 will be obviously uncountable. Okay, so option A is correct. It is asking what is which one of the following set are uncountable. So option 1 is uncountable, so it is correct. Now option 2. Going to option 2. Option 2 which I name it S2. S2 with the set of all A comma B belongs to R2 such that A plus B belongs to rational number. Okay, so I am writing this A comma B such belongs to R2 such that A plus B equal to R, and R is a rational number. You can say from here you can write B equal to R minus A. So from here you can write B equal to R minus A belongs to R2. Okay, so that R belongs to rational number. But R maybe whatever may be rational number. Okay, so I can choose R equal to 0. If I choose R equal to 0, then this set contains this set. You can easily tell that this set contains this set. A comma minus A belongs to R2 such that A belongs to R. Okay, now this kind of a real number. So this is an uncountable choice. This kind of real number. This is uncountable choice. So total cardinality of this set will be C square, and C square will be nothing but continuum. So this set contains this set. Okay, S2 cardinality must be greater than equal to this set cardinality. Okay, because this set contains this set contains this set. Okay, and during that this set S2 will contain this set A comma minus A such that A belongs to R. Okay, so from here you can say cardinality of S2 nothing but greater than equal to cardinality of this set A comma minus A such that A belongs to R. Okay, so see this set cardinality continuum, so this set must be cardinality continuum, means uncountable. Okay, so this set is also uncountable. So option 2 is also correct. Now go to the option 3. What is option 3? S3. Let S3 equal to A comma B belongs to R2 such that AB belongs to K. Okay, A belongs to integer, so you can assume it. Let A comma B belongs to R2 such that AB equal to into some integer, so it will be K, and K will be integer. Okay, so from here you can write B equal to K by A. So you can write K by A. Okay, belongs to R2, or you can say such that A belongs to R. Okay, and K is some integer. K is some integer. Now you can easily tell that if you put K is integer, so you can put K equal to 1 also. So if put K equal to 1, then this set contains this set obviously. Okay, A obviously non-zero because A is dividing, so A is non-zero. So A is non-zero real number. Okay, now S2 contains this set, so cardinality of S2 must be greater equal to cardinality of this set A comma 1 by such that A is non-zero real number. Okay, now you can tell me how many cardinality of this set. Okay, since A is non-zero real number, so this set is this quantity A has uncountable choice, so cardinality continuum. in this set, this also has ungrounded measures. So C cross C cross C will be C square, C cross C will be A and C. So this set is cardinality greater than C, means C is continuum. Since this set is cardinality greater than C is continuum, you all know if it is a real number, its cardinality greater than continuum, it must be cardinality continuum. There are no set which in subset of real number such that whose cardinality is greater than continuum, so it must be cardinality continuum. So continuum is uncountable, so this set is also uncountable. Okay, so option 3 is also right. So option 3 is also right. Now last option, option 4. Okay, option 4. Unit S4. S4 is A comma B belongs to R2. A comma B belongs to R2 such that A comma B belongs to rational number. Okay. Now you can say A is rational number, A is rational number. So it is nothing but a set Q cross Q. Now all know if since Q is countable, so it's countable. So it's starting about two countable set. So it is again countable. Okay. So it's countable. So it is not uncountable. So this is incorrect option. So option 4 is incorrect. Okay. So in this question, correct option will be 1, 2, and 3. Okay, these are correct option. So hope you understand the solution. Okay, so today in this video we will discuss more about one, 2, 3, and this is 4, and this is 5 questions. Today in video we will discuss three questions from part B and 2 questions from part C. Okay, so in upcoming videos we will discuss more questions that are left. Okay, in this PDF. So please subscribe my channel and follow my channel, and hope you get new thing from my videos. Okay, so and I will continue this video regularly. Okay, so please subscribe my channel and follow my channel, and thanks for watching. Thank you.